In example 1, we've got quite a few problems. We have A through, looks like H here to knock out. So just stick with me through this one, and you can fast forward or back up to whatever you need to. In part A, we want to find the measure of angle 1 if C is parallel to D. These angles here with the expressions, those are going to be alternate exterior angles, and we know that alternate exterior angles are congruent. So to solve for x, we're simply going to set each of those measures equal to each other. We can subtract 2x here, subtract 8, 3x is equal to negative 12, divide by 3, and x is negative 4. To find the measure of this angle, you can do 5 times negative 4 plus 8, which is negative 12, and that would probably be degrees. Unfortunately, though, this isn't on the coordinate plane, so it's not possible to have any angle measures that are less than 0. So, although x would be negative 4 here for this one, it's what balances these out. 2 times negative 4 is negative 8, negative 8 minus 4 is negative 12. So those are the same angle size. This just doesn't make any sense, though. So I'm going to put a question mark here. Something is wrong with this problem. For the next one, C is parallel to D. We want to find the measure of angle 1. If we look at the expressions, we can see that these are alternate interior angles. Alternate interior angles are congruent, so we're going to set each of these equal to each other. Subtracting 2x from each side, we'll have 5x minus 12 is equal to 38. If we add 12 to each side, 5x will be equal to 50. Dividing by 5, x is equal to 10. All we need to do is resubstitute in here or here. We should get the same angle measure, and that'll be also the measure of angle 1. So 7 times 10 minus 12 is what we need. 70 minus 12 is 58. So the measure of angle 1 here, which is a vertical angle with this angle, meaning that they would be congruent, is 58 degrees. In part C, we have two angle expressions. We want to find the measure of angle 1. We're also told that C is parallel to D. These are alternate exterior angles. Alternate exterior angles are congruent, meaning their measures are equal. So we'll set 2x plus 5 equal to 3x minus 13. We could subtract 2x from each side, so that'll be x minus 13. Add 13 to each side, so x will be 18. We want to find the measure of this angle, and then we know that this angle here and angle 1 are supplementary. So let's try to find the measure of this angle, then we'll subtract that from 180 and we'll be able to find the measure of angle 1 here. So 2 times 18 plus 5 would be the measure. It's 36 plus 5, or 41. So if this angle is 41 degrees, measure of angle 1 would be 180 minus 41, or 139. Keep in mind that diagrams may not be drawn to scale, so even though it looks like this angle is larger than 90 degrees, it's actually 41. In reality, this transversal would probably be tilted the other direction. If C is parallel to D, we're going to solve for both x and y. If we look at these two expressions for these angles, we can see that they're alternate interior angles, and alternate interior angles are congruent. We'll set the measures equal. Subtract 4x from each side, we're left with x plus 25 is equal to 35. Subtract 25 from each side, and you get x to be 10. Let's try to figure out the measure of this angle, and then these two angles are a linear pair, they're supplementary, so we'll be able to figure out y. So to figure out the measure of this angle, we'll take 5 times x, which we think is 10, plus 25, so that's 50 plus 25, or 75 degrees. 105 is supplementary to 75. If we add these two together, we get 180. So y will be 105. Just a few more to do here. We've got EF, and I think there's a G and an H as well. If we look at these two angles here and here, we can tell that they're in correspondingly the same location. In other words, if we took this whole piece and shifted it down, they would line up right on top of each other. And we know that those are congruent. Corresponding angles are congruent. We can subtract 2x from each side, so x plus 5 will be 10. Subtract 5 from each side, and x will be 5. To find the measure of angle 1, we'll need to find the measure of this angle, and we know that those two are supplementary. So we'll take 3 times 5 plus 5, which is 15 plus 5, or 20 degrees. So if the measure of this angle is 20 degrees, the measure of angle 1 must be 160. In this example, we were given these two angles here. We want to find the measure of angle 1. And it turns out that all three of these will have the same measure. You can see that this angle is in the correspondingly same location as angle 1. We call them corresponding angles. And if we can just find the measure here or here, then that'll be the same as the measure of angle 1. Also, the expressions here, those angles are vertical angles, so their measures must be equal. We'll subtract 2x from each side, add 12, and divide by 5. So x will be 10. To find the measure of this angle, we'll take 2 times x, which is 10, plus 38, or 20 plus 38, which is 58 degrees. And we know that's going to be the same as the measure of angle 1. Alright, just a couple more. We're going to look here and we notice that C is parallel to D. We're going to try to find the measure of angle 1 again. If we can just find the measure of this angle, 1 and that angle are going to have the same measure. They're vertical angles. If we notice though, here we have two angles on the inside. And they don't appear to be the same. This angle looks like it's less than 90, and although the diagram might lie, you can use it to figure out the relationship between these two. This angle looks like it's bigger than 90, and they're definitely not the same. As a matter of fact, these are same-side interior angles. Same-side interior angles are supplementary. In other words, their measures add or sum to 180 degrees. So we're going to take 4x plus 5, add 3x plus 35, set that equal to 180. We'll combine like terms on the left. 4x and 3x is 7x, 5 and 35 is 40. We'll subtract 40 here. 7x is 140, divide by 7, and x will be 20. Remember, we need to choose this angle specifically because it is a vertical angle with angle 1, and their measures will be the same, and it'll ease our burden here just a little bit. So we'll take 4 times x, which is 20, plus 5. Using order of operations, we find that the measure of this angle is 85 degrees, thus the measure of angle 1 is also 85 degrees. We'll solve for both x and y here. You can do whichever one you want first. I think it's going to be nice and easy though if we figure out y to begin with. We know that those two angles right there are, the measures are equal. They're vertical angles, so we can set their measures equal to each other. We'll subtract 6 here, so we get 30 is equal to 8y, and divide by 8. So we get y to be 15 over 4. We also know that 6x plus 10 plus 36 must be equal to 180. This angle and this angle form a linear pair. So we'll add or combine like terms here on this side, so that's going to be 46. And we'll subtract 46 here from 180. 6x is equal to 134. We'll divide by 6. And let's see. Don't know if this one is going to work out great for us as far as getting an integer answer, but that's okay. We could divide each one of these by 2, and so that would be, I think, 77. No, not 77. Wow, 67. How about that? Over 3. 6 plus 7 is 13, therefore 67 is not divisible by 3. 13 isn't divisible by 3. And you could check this in your calculator if you wanted. but we should have 67 over 3.